When you're on board a spaceship, one of the coolest things to do is to float to the window and watch a sunrise. And not just for the colors, but for the moment that the sun slices over the edge of the Earth as you race around it. It's this overwhelming reminder of the raw, endless power and energy that's pouring through our solar system. The energy that powers life itself, and it powers our journey beyond our world. But as we've stepped into this new space age of human history, we're facing a new challenge. How do we fuel our dreams sustainably? It's leading us towards a future that right now can seem sort of like science fiction. Today, I'm joined by Lauren Lyons. She's an incredibly accomplished aerospace consultant, engineer, former SpaceX and Blue Origin mission lead, and we're going to explore how space and energy are more connected than ever. This is On Energy. Lauren, welcome to the podcast.
Thank you for having me and for that awesome introduction. I'm just going to transcribe that and put that on my bio.
So originally, I was inspired by space flight when I was a little kid at W.H. Morden Elementary in Oakville, Ontario, on Third Line. What inspired me was watching the very first human beings risk everything and successfully walk on the moon. It just took my breath away. So let's just start at your beginning. What sparked your interest in the things that you've done? Was it something that happened while you were at Archer School?
Yes. And it's so interesting because so many people have these beautiful stories of, I watched the moon landing or I saw the spacewalk. Mine is way less interesting. My school was beginning a robotics competition program, the first robotics competition. They were recruiting people to join the program. It was the first time they were having this program in the school. And I wasn't very interested. But then they said the national championship is at Disney World. And I said, sign me up because I love Disney. And I was ruined from then on.
Cool. So you made your way to space via Disney.
Pretty much. Yep. Some people have Star Wars. I had robotics competition.
You've had an incredible career in space exploration and space technology with multiple companies. But what has maintained your passion for it?
Yeah, I guess, it's actually going back to First Robotics, the founder, Dean Kamen. I remember him saying this, and it stuck with me ever since. He said, you have to know the difference between what's fun and what's important. And the best thing is if you can combine the two. And to me, that's what space does. It's both. I mean, come on, like you're looking at galaxies and planets and like searching for life on other bodies. And just the idea of life beyond Earth and what that can teach us about life on Earth, it just blows my mind. But when you also think it's not just fun, these are existential questions that are important to humanity, but also, so much of the technology that we develop in space is applicable back on Earth. And so when I worked on Starlink, as for example, this wasn't, for funsies. It was, hey, what if we were able to give broadband internet to people all over the world, no matter where you are, whether you're connected to fiber or not? And everything from, isn't it cool to explore other planets, to how can we use space to provide connectivity and connect people on Earth to one another? And so it's a fun and important. It's kind of hard to not be addicted to something like that.
So whether we're putting people into space or operating that rover on Mars, in order to accomplish that, and you're hyper aware of it because of all of the different ways that you've contributed over the years, but it's a blend of engineering and of just raw physics, but also of human vision to make those things happen. So given that necessity for a whole village to be able to enable space flight, we're talking about energy today, and energy as it enables space flight, and then as we can use energy from space flight for life here on Earth. How has your experience in all of the things that you've done made you think differently about energy, both in space and how we use it here on Earth?
Great question. I will use maybe an anecdote to describe this. I was working on a mission that had some problems with a solar array, which is how we power spacecraft generally in space. And we had to fly the vehicle differently in space to accommodate this issue. And so we knew that, right? So we go, okay, this is what we have to do. But then you start to go, okay, if we fly that vehicle differently to accommodate this issue, what else is going to be impacted by that? And you start going through the list of all the systems on the spacecraft, and you start thinking about what happens to the batteries, what happens to the flight computer, what happens to the air inside of the spacecraft. Do you end up condensing water because you're not able to control the temperature as well? Are there certain systems you have to power on or power off to maintain the power that you do have to be able to use that effectively? And when you start thinking of something just as simple as what happens if we have less energy than we had anticipated, and the knockdown effects and follow-on effects across the entire spacecraft, it was just remarkable.
Right.
And so on Earth, you start to then, I think you start to look at the world in that same way. And as you look at places right now where, whether it's a geopolitical issue where you don't have access to natural gas like you used to, and you start to go, what are all the different impacts of not having access to that energy? It's kind of this sort of systems thinking that you start to adopt when you start by looking at something as small as a spacecraft. You then apply that more broadly, and you realize everything is just this system, and for which energy is the key component.
Yeah, and Earth is just a big solar-powered system.
100%. Yep.
When I was born, no one had ever flown in space. I mean, Sputnik, the very first thing that we put in orbit around the world, was not that long ago, 1957, just not too far before I was born.
Yeah.
But I'd like to hear your points on what do you think the major objective of space travel is? Is it to get all our eggs out of one basket? Be interplanetary, avoid the next great big extinction event or plagues on the surface, or is it to orbit and understand the world? What do you see as why it is that we're spending this energy in order to allow space travel to happen?
Oh, yeah. I think that there's so many answers to that question depending on who you are, but I've seen them come in a few different buckets. One of them, as you said, is we need a backup plan. What happens if Earth is too damaged or whatever it might be, right? There's folks who really believe that is the core thing to go after. This is behind a lot of the people that believe that humans should populate Mars. So that's one perspective. I think I would lump another one into this category of there's money to be made in space. There are materials that you can mine from the moon, mine from asteroids that you could bring back to Earth to put in electronics, to put in fission reactors. And these are things that help Earth, but it also helps people make money, let's be real. And so there's a lot of private investment right now that's going into space, looking at very commercial applications. And then I would say there's this other piece, which I think is the one that inspires me the most. And it's it's just good to know things. As a species, we are better for knowing about Jupiter. We're better for knowing more about Mars, for knowing more about our sun, for knowing about solar systems and star systems outside of our own. And I think that just human knowledge in and of itself is of utility. And maybe I'd say the fourth one is something that is ever evolving, which is because we are doing this really complicated thing that is, like we say, it's the last frontier, right? We're doing this thing when nobody really, a lot of times we have no idea what we're doing. We're just out there, we give it a shot, we see what happens, we learn from it. And a large percentage of the time, you learn something really, really useful that can be applied down on Earth. And sometimes it's completely unintentional. And I think that's another thing that can't be discounted.
Yeah, I like that list of 4 things. I think that's a good list. Let's talk about that last one. If this is a podcast about energy, so what sort of developments are we making in spaceflight or to support spaceflight that have benefits, energy technology that has benefits back on Earth?
So many. And some of them intentional, some of them, again, just you discover things. Maybe let's start with something as simple as solar array technology. So most satellites, as you know, are powered by solar panels. And we have solar panels on Earth and we have them in space. Now, in space, that environment is way more complicated. The temperature swings, you get much hotter, you get much colder. You have to be concerned about contamination. You're in this vacuum environment, which could really disrupt the construction of the solar panels. You are trying to minimize the mass and the size of these things because, they have to fit inside a rocket in order to go to space. And so engineers get really, really good at packing them up and making them really small in order to squeeze them inside the rocket.
It always reminds me of like a butterfly, in the cocoon, that you look at this lumpy looking streamlined thing, but then somehow those big wings, which in this case are solar arrays, manage to unfurl. And I'm always kind of like some sort of strange origami of solar arrays.
Yeah, it's remarkable. So when you start looking at all of these constraints in order to get these things up there, you start learning a ton about how to make solar panels on Earth more efficient, not just from a power consumption and conversion perspective, but also how do you make them small? How do you make them lightweight? And how do you make them really, really effective? So that's one thing. I think another one that's super interesting to me is energy storage. Like you have what you have. Like it's a closed system. No, it's not entirely closed. You have the sun with radiation coming through, but you have what you have up there, and the ability to come up with really unique ways to store that energy that you're getting from the sun into batteries to be able to be used and in a very efficient way. That's something that spaceflight has taught us a ton about. And we are seeing this in the way electric car batteries are made.
Yeah, I agree with you on both. I just want to pick your brain briefly on one more thing, and then we'll get into sort of what's going on right now in energy and space. But it's expensive, obviously, and not very many people get to go, and it's super complex. So I'm sure you've thought about it because you've rationalized it in your own mind that this is what you've been working a large part of your life on. But why do you think space exploration is worth the investment?
I'm not going to sit here and say, it's super cheap, no money goes on it. This is not true. But what I will say is, if you look at even just the top 3 countries that spend money on space, it's still less than 1% of their national budgets. And when you look at the bottom 7, or the next 7, which again are the biggest countries spending the most on space exploration, the highest amount that any one of those countries is spending is 0.3% of their national budget. And so I think it's always good to just put it into context. Like, how much money are we really talking about here when it comes to government spending? And again, not to say that it's not money, it is, but it's not as much as some people might think. All right, now, that's still billions in some cases, hundreds of billions in other cases, right? So why does that matter? And especially I'll talk about why I believe it matters and why I still think it's worth working on. For me personally, it really is about the fact that I think we can walk and chew gum at the same time. I just do. I think, again, exploration, learning about our planet, learning about other planets, learning about our moon, that these things are inherently valuable to humanity. I believe that so much also, without even forcing it, so much of what's happening in space, how's money made in space? I'll tell you. Selling satellite TV, satellite internet, GPS, communication systems, this is weather systems. These are the things that are the only things with a real business model to date right now in space. And those things overwhelmingly help Earth. Maybe another thing I would say is, and this is the part that's interesting to me about the future, is One, we're using satellites over, flying in space to look down on the Earth and to monitor climate change. This is very important. But I think from the energy perspective, what's quite interesting is you've got people looking at ways to go to the moon, go to asteroids, and mine for materials that you could bring back to Earth to put in our nuclear fission reactors to build better solar panels, materials that are rare on the Earth or more abundant out in space. And I think that's worth taking a look at, honestly.
Um,
What do you say when people ask you that?
well, when you talk about monitoring Earth, it's nice to put, if I asked you right now, um, is the water melting or freezing in Greenland, and how much? Or in Antarctica? Because there's people that talk about how climate change is melting Antarctica or melting Greenland. But if I said, okay, wherever you are in the world right now, or wherever I am, what's the answer? You can't tell. Even if I said, okay, I'm going to give you $10 million and 5 ships and a whole crew, go find out. Even still, you're floating your little ship around Antarctica or Greenland. You're not going to be able to answer the question. But if you just put a little radar altimeter or something that has a decent LiDAR mapping on a small satellite, and it goes around the world every couple hours and it maps the entirety of Greenland on a recurring basis, it allows you to truly understand the state of a really complicated problem and part of the world that you can't even actually measure for anything like the same cost here on the surface of the Earth. And so there are some real efficiencies in space travel.
That's good. Yeah.
Let's come back to energy. Unlike Earth, there's no place to plug your extension cord in. There is no grid in space. There's no big infrastructure. So what are some of the energy needs, and what are some of the solutions we're looking at, innovations for what we need in order to be traveling out into space from an energy point of view?
So solar arrays are only going to get you so far, especially if you start going further away from the Earth. Now, we've seen some satellites using these massive solar arrays with going to Jupiter, right? It means you have to be really, really careful and very, 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 I would say, have a bit of a scarcity mentality, frankly, around the science that you can do, around the power that you can consume. Now, let's say you put people on a spacecraft that's going that far. It gets even bigger. It's even more because they have to breathe, they have to eat, they have to talk, they have to, something's got to power these life support systems that are keeping them alive. They weigh more than a few science instruments. And so you've got all sorts of technologies that people are looking at. Now, look, solar is going to continue to be the gold standard for the time being, but we've got folks thinking about, what would it mean to have like a water-powered thruster instead of having to lug all of these propellants that are only made on Earth and bring them to space?
So you mentioned that the further you get from the sun, of course, it fades with distance, and it's a quarter when you get out to some of the other planets, or even less. Mm-hmm. But the sun is constantly shining when there's nothing in the way, so it's a constant power source up there. But how do you then use water as a way to, like, do you squirt it, or how do you turn the energy that you're collecting from the solar panels and a little jug of water? How do you make your rocket ship go? Let's say you've landed on the moon. There's like 100 billion gallons of water frozen into the craters of the moon. So you've harvested some of that, and now you want to bring some of that on your spaceship and drive around. So how does it work?
I was just thinking about like water thrusters, and I'm not sure I fully understand how those work.
You could just squirt water. You could boil it. Mm-hmm. If you can make it hot enough, you can boil it, and it's like a steam kettle to push it.
Yeah.
Or if you can, I work with a company called Momentus, and they actually have a couple of them in orbit around the world, and they put like a little microwave in the middle of their spaceship. Little microwave, the thing that makes your microwave oven work. And we collect energy from the sun, we run this little microwave, and it doesn't just boil the water, but it puts so much energy into the water that it breaks it down into a plasma, like an energy plasma. So it
Interesting.
comes squirting out the back of the rocket, not just as liquid water or as vaporized water, but actually super high energy plasma.
Wow.
And that way you can get a significant amount of thrust to drive your little spaceship around just from solar power and water. It's
That's
pretty
awesome.
cool, elegant first way to use electricity up there, and water.
Yeah.
But but what else? What else is out there in the future for using energy in space, or other ways to tap into energy in space?
Let's talk about the Mars rovers for a second. So they have solar. If they were to only use solar arrays, because there's so many dust storms on Mars, they would quickly just be covered in dust and the sun wouldn't get through to them, right? So it's not the most effective way to power these rovers. So what they have are these MMRTGs, or multi-mission radioisotope thermoelectric generators. This is why they call it MMRTG. And they have these devices that are on these rovers. And so basically you've got this chunk of plutonium that is naturally decaying. And as it's decaying, it's releasing heat. And they have these thermocouples that are on the spacecraft that take the heat and the temperature difference between the cold outside and this heat coming from this isotope, and you're able to generate electricity from that. And this is how these things are being powered. Now, there are very few of these in the world. NASA runs them and makes them, but there are some startup companies that are developing MMRTGs that aren't necessarily coming from NASA, trying to come up with low cost ways in order to build those. So that's really interesting. But then on the other side, just straight up fission. You've got people trying to build like little fission reactors that can power stuff on the moon, that can power spacecraft. And interestingly, it's kind of the opposite, Chris, of like what we were talking about. You do something in space and you apply it to Earth. The companies that are trying to do these small fission reactors, they're actually starting on Earth first. And they're going to take what they have learned and then start to apply it to space. And it kind of makes sense, right? It's, this stuff is expensive to develop, and there's quite a demand for this type of technology on Earth. And so getting your sea legs on Earth, getting some revenue, some real money in order to fund the research in space, that's the strategy with a number of these companies.
I know that in the United States, Lockheed Martin, and in the United Kingdom, Rolls-Royce, they are now developing nuclear rocket engines, because if we're going to get from here to Mars with a robot, a robot doesn't really care if it takes 6 months. But if you've got people on board,
Yeah.
that's a lot of cans of tuna and stuff to get. And a lot of stuff could go wrong if it takes 6 months to get there. So
Yeah.
trying to develop an engine that makes travel efficient is one of the big challenges. But it brings us back to energy here, and that is, how do we not have spaceflight just be a consumer of energy, or is that okay? And this is more of a philosophical question coming back to you. Should one of the purposes of spaceflight be to collect and advance and return energy to Earth? Or should we use energy in order to explore and develop, and recognize that energy is just one of the costs of bringing those capabilities back to Earth? How do you see that fitting together?
As I love to say, ¿por qué no los dos? Both.
Wow.
You've got it's space again. If we are to believe or work off the hypothesis that there is inherent value in exploration, it takes energy. And that's just how it works. And some percentage of the time, You're going to do that, and then you're going to learn some stuff that's really useful for Earth. You don't really know out of the gate sometimes if that is going to be the learning, but it shows up in some really unexpected ways sometimes, right? Like with these MMRTGs, what did we learn? A lot, right? Just like scientifically, but also how do you contain that heat? How do you contain the plutonium? How do you make sure that under extreme temperature changes that you don't have a leak? How do you make it survive the aggressive launch environment? These are things that we can then take back down to, or we have taken back down to Earth and going, okay, how do we actually seal off these things? If we can do it in space under those conditions, oh yeah, you better bet you can do it in a desert in the middle of Earth, right? With data centers, they consume remarkable amounts of energy, especially with AI, and it's just getting worse and worse and worse. And people are trying to figure out, do we hook nuclear reactors up to these things? Like, what do we do? Because we can't stop AI, it's so important. There are some companies, and people have different opinions about this, that are looking to put these data centers in space. And what if we harness this abundant energy from the sun in order to power these things?
And we're just in the early days of that, but I'm really curious to see how that's going to unfold. I want to ask you a personal question. Something happened fairly recently that you had a big hand in. What were you doing, and how did you feel when Firefly Company's Blue Ghost successfully landed on the moon? What was that like for you?
My heart beating out of my chest and immediately texting my friends there saying congratulations on the landing. And I think lunar is another example of this cost question. Vast, and the private space station company, they didn't go out and raise a bunch of venture capital, because if you're going to go and raise venture capital for this, you have to have a clear reason or a clear path to 10xing at least the amount of money that those investors put in over a period of time. And because this is so speculative, it's like really hard to make that case. So Vast is self-financed, at least in the beginning, and their revenue sources are going to be tourism. But in terms of the R&D, it came through private financing from an individual. Now, we talk about these lunar landers. Now, there are some, let's take Blue Origin's lunar lander. Jeff Bezos is funding the development of that. They also have a NASA contract, but the original funding of it came through a private individual. These smaller lunar landers like Fireflies, these are the first that really aren't coming through some high net worth individual that's just passionate about the moon. These were real contracts that came from NASA, and they weren't tremendous amounts of money. In fact, I would guarantee you that almost all of those companies, if not all of them, took a loss on, like, financially on building these things. But what it has shown is that with much fewer resources, much tighter timelines, that you can scrappily pull these things together and successfully land on the moon. And I believe Firefly was the first of the commercial companies, not to land, but to land and to still be standing up at the end and to complete their mission. And what that's going to unlock, so much of what I say is like, it's all hypothetical until it's real. The hardest part is like executing to the point where you can prove it, where you can show existence proof. And then as soon as something hits that moon and you go, wow, they did it, that's when the ideas start to flicker. This is when people start to take it seriously. And then you start coming up with, what are the applications? Some people have already been thinking about them, but once you see it and you go, oh, wait, this is real, this can be done, your brain really starts coming up with the new ideas.
And speaking specifically of the moon, it's been sitting there being blasted by the sun in orbit around the world for whatever, 4.5 billion years. And that has deposited a sort of a version of helium that can be used in fusion energy without a lot of radioactive byproducts. It's helium-3, a certain variant of helium. Have you ever looked into helium-3 and thought about that as another reason to fly in space?
Yeah, and mostly because there's a number of companies that have been founded on that. The former CEO of Blue Origin founded a company called Interloon, and that's its goal. They're like, we're going to mine helium-3 and we're going to bring it back to Earth. And we're going to put it in medical technologies like MRIs, CT, or I don't know which one of them, but like these types of imaging technologies. And we're going to sell them to fusion companies. And so this one is very, very interesting to me. It has an application on Earth that is that using this material from space is going to give it a significant increase in performance. And that these materials are either too difficult to get from the Earth or they're too rare. There's not enough of it and they're more abundant in space. And so I think if you can show that something that's very important to us, such as fusion, can be done in a much grander scale and a much more efficient scale with this other material that is more abundant someplace else or only in existence someplace else, then it starts to make sense. But if we're saying, hey, there's rocks in space, they're really cool. We also got rocks on Earth. Let's get some space rocks. Like, way less interesting. I'm not really going to sign up for that one.
So let's say our technology continues to advance, and now we have the capability to get minerals back or elements back from an asteroid. So just to keep it simple, how's that help? How's it going to work?
So there's so many minerals and rare earth minerals, things we call rare earths, that are rare on Earth, but abundant out there. And, just for example, lithium, that we could bring that back from space. And as you know, lithium is a really key part of batteries, the batteries that power electrical vehicles. And when we start talking about having all these other sorts of, maybe it's an electric airplane, all of these things from a sustainability perspective, we really care about that are rare and hard to get, or the process of getting them is really damaging to the environment and to the local people in that environment. All that goes away when you can bring them from space.
I agree. Building the business case is so important, but it's still early. This has all happened within much less than one human lifetime. But I just want you to look, just as we wrap up here now, Lauren, looking at the future of energy in space, both as a way to get there and as a way to bring energy back to Earth. What changes do you expect in the next 5 years? And then what are you hoping to see by 2050?
Okay, so I'm going to say something that some people have reactions to. And I used to be one of these people. I used to say, I don't want to hear about this. But I have now changed my mind. And that's around space-based solar power. Basically, this is putting big satellites and mirrors and antennas in space that can collect the power from the sun, and beam it down to Earth, either through lasers or microwaves. And so, these ideas kind of originated in science fiction, and in the perception of these things are these multi-trillion-dollar projects that are going to take, 10,000 launches in order to get the material up there. And it's going to cost all this money and take, 100 years to flesh out. And I think that perspective around it got people very much in this sort of mentality of saying, why waste time on that when we can just focus on fusion or focus on other, Earth-based systems? Now, what I think has changed my mind on it is meeting some companies that have said, you know what, maybe there's a different way to do this that isn't just that approach. What if we did it with multiple satellites that are flying in a lower orbit? What if we use something maybe other than microwaves? And there's some really interesting work that's happening right now on trying to figure out maybe it's not not going to give you as abundant power than that type of system would, but it might be good enough.
So I think that is a definite possibility, to have the big empty, void blackness of space directly collecting the energy from the sun and then directing it straight down to Earth. But what impact does that have? How does it actually make things more sustainable on the surface?
So, solar panels are amazing. We love solar arrays. We love solar panels, but there's so many places in the world where solar just doesn't work. And that's because there's cloud cover, or it's, in the night for a significant portion of the year, these sort of upper and lower latitudes. And so if you could have essentially the power of near 24 hours, 7 days a week, 365 sunlight that can go through the clouds and be transmitted down to Earth to be distributed through the electrical grid, that would be remarkable for places that otherwise don't have access to solar power. I think another thing is, with a lot of renewable energy sources, big part of the problem is they're intermittent, right? You can't really go to a full electricity only grid or sort of sustainable renewable only grid, because when we talk about wind power, when we talk about solar panel or solar power, when it's nighttime, no solar. When the wind's not blowing, no wind. But this could be a constant source of renewable energy that is not intermittent. And that would just be a massive, massive game changer.
And I agree with you. There's a lot of companies working on that right now that think they're going to be able to financially be viable in the relatively short term. So yeah, I'm excited on that on a 5-year horizon. But how about 2050? I mean, 2050 sounds like a long time. 25 years ago was the year 2000. That wasn't that long ago.
I know.
Anyway, so if you flip that around forwards, 2050, what from a space energy point of view, what are you hoping to see by 2050?
I'm going to be redundant. I believe that by 2025, we will, and this is quite a statement, I think we will certainly have demonstrated that space-based solar power can be done, and that you can have not just detectable power, but useful power transmitted from space to Earth. I think some of these sort of lower Earth orbit options are going to be out there. I think they're going to be used probably by our defense departments to get started. That's usually how things begin. But I also believe that some of these grander vision things that involve bringing materials from other worlds to Earth orbit and doing the in-space assembly, I think we're going to see something like that. I'm not convinced we'll necessarily have we'll be off the grid and we'll be using, or that our grid will be sourced through the sun exclusively. I don't think that's true, but I think we will have made a lot of progress on this.
Thank you so much, Lauren, for the time and for agreeing to be part of the podcast here today. But also, I just want to thank you for the work that you do, the multifaceted work you've done so far, and the people that you are enabling and inspiring today, self-included. Thanks, Lauren.
Thank you. This was awesome.
I just want to close with sort of a call to action, but not from me, from a man that I met a couple times who thought deeper than almost all of us, and that is Professor Stephen Hawking. And even when he, at the end of his life, when his body was failing him and he was crippled in a wheelchair, couldn't even move his head, he said, remember to look up at the stars and not down at your shoes. Try and make sense of what you see and wonder about what makes the universe exist. Be curious. And to me, when we're talking about space and energy, it's that resting our vision up off our shoes and up to the universe, being curious, and being part of the first in history to be able to make that part of life and part of sustainability here on Earth. Thanks very much for joining in today. I remind you, in addition to all the things that Lauren and I were talking about, but just how important it is to have your own personal dreams and to make daily decisions that help move you and your life closer to those dreams, and most of all, find the energy to enjoy this amazing ride. Until next time, I'm Chris Hadfield on Energy.
Chris Hadfield on Energy is brought to you in part by Enbridge. For many decades, Enbridge has safely and reliably delivered the energy that helps power homes, industries, and communities. Today, they're investing in the energy systems that fuel people's quality of life. Life takes energy. That's why Enbridge is shaping a better energy future, because tomorrow is on. Find out more at enbridge.com.